Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. Thank you so much for joining us once again on Did You Know? The ESCO HVAC Show. Unfortunately, I can't be here in person this week. So this week, I'm in Washington, D.C. at the Johnstone Supply Spring Expo, where I'll be doing a class on A2L refrigerants, how to properly handle refrigerants, and what types of fire suppression could be required, because there are a lot of things that are changing in our industry, right? It's what we keep talking about, how fast our industry is moving in new directions. And we are here to be able to bring all this information to you every week. So thanks for joining us, and we're going to go back through and take a look at some of the highlights of our shows over the last 6 months. Can you believe that? It's already been 6 months that we've been hanging out here in our village of HVAC, refrigeration, and building science professionals. So in the chat, let us know what ones you like, what videos have been informative to you, and let us know what other topics that we can discuss and what other trainers that you want to have here on the show, so we can talk about these things together as a group, as our village. So thanks again, and I'll see you next week on Did You Know? The ESCO HVAC Show.
Okay, Cliff. Well, let's start out with this one. You've probably seen this many a times in different graphics, different flavors and sizes. Notice the green box there. Well, prior to the 1930s, before we came up with R12, that was actually invented in Dayton, Ohio, just down the road from where I'm at, by a man named Kettery. And it was for GM, as Cliff touched on a little bit. But as you can see, the beginning of the turn of the century, we had, refrigerants like sulfur dioxide, ammonia. And so we were happy to see R12 come along for safety reasons, basically.
Right, to replace the flammable refrigerants.
Exactly, spot on. And as you can see in the green box, many of these refrigerants we have utilized in the air conditioning industry, and the refrigerants were always classified as A1. Some people say no toxicity or no flammability, and as Cliff touched on very well, I usually say low, because anything parts per million, including CO2, will asphyxiate you, so you have to be careful with that. And if you add enough heat to R22 even, it will, obviously explode. So, but today's conversation is going to be, if you will, the new kid on the block, the A2Ls. And then we're getting to the HFOs. We went from R22 to HCFCs. Look, it's a little lower than the ODP, as you can see, but it's higher in GWP, because we weren't really focused on that, were we?
Not at the time. No, we weren't.
If you think about it, we were focused on that ozone. It was putting that fire out. It's kind of like when we first started in the industry, asbestos was really a bad word, and now mold became that new asbestos word, Exactly. So it's kind of the same thing from ozone to GWP.
Transitioned along the path.
Exactly. The things you don't know. You don't know what you don't know.
Exactly right.
So from R22, then we moved into what we have. Believe it or not, when Jeff pointed this out to me the other day, 1990s, that's 30 years ago.
Isn't that crazy?
Seems like yesterday, Yeah. It seems like yesterday. I remember
1991, we got the initial patent for R410A. Do what?
When he said that to me, I thought, has it really been that long? But it has. So it's not like we're changing every 2 years, It's had a good ride. And so now we still don't have any ODP, but it has a higher GWP. We actually went up, and I'll show you on the next slide, I believe, where we actually went up higher in GWP from 410A from R22. But again, the fire to put out then was that ozone depletion, okay?
That's exactly
and here we are today at HFOs. HFO blends, examples would be R32, 454B from Chemours, no ODP, very low GWP. Look, this is what it's all about. this whole conversation, no matter what flavor you're choosing, what application, it's about getting that environmental impact lower, raising the efficiency of our equipment, and thirdly, getting those emissions down. Okay, and and that's really what it's all about. And as Cliff touched on earlier, these numbers come from what we refer to as ASHRAE standard 34. So let's slip on to the next slide, if you would, Cliff. Yeah. So this one here, it's here we're talking about. They're blocked right now on the screen with the 1234YF, but really what they're saying here is HFOs. They're double bonded. Okay, and what that means is they break up easier in the atmosphere. Okay, you can't see it on the right hand where it says double bonded, but those two molecules are carbon molecules. And anytime you have two molecules that are the same connected, it's referred to as double bonded, and they break up much quicker. I mean, we're looking at the example there they're giving at 134A is the difference from 14 years in the atmosphere as opposed to 12 days to 1234. The bottom line is most all refrigerants that I can think of, with the exception of maybe ammonia, has some global warming potential. And that number is based off CO2. It's really by metric carbons, basically. And but that's what that's for. And I do apologize. I had the lineup evidently different than what I was given. So.
No, and so that's a really interesting point. When we talk about the HFO, we really are talking about a synthetically modified HFC that has a different bond on our carbon-based atoms. So we're using that olefin base or an alkene base, which does that double bonding of the refrigerant that allows it to break up faster as it enters into the atmosphere. That's the reason we have that lower GWP off of our refrigerant. Very stable at lower atmospheric and under pressure conditions. And then as we introduce into higher atmospheres, it is easy to break down. So its longevity has been significantly reduced over our HFC refrigerants that we've seen in the past. Has anyone ever explained to you how communicating HVAC systems work? What principle they come from? It's a very important topic that we really don't talk about a whole lot in the industry, and that's what we're here today to do, is discuss how communicating systems work and get a better understanding of what that communicating thermostat does in relationship to the entire system. If we look at communicating systems in general, they really do have their roots in the same technology. I'm not going to say that they all talk the same way. We'll just say that they talk on the same network, and they may speak slightly different languages, but they all have their roots in the same type of communicating system. If we look at this reference from Eaton will tell us that the RS-485 system has been around for a very long time, really developed back in the 1980s, and it's based on a 5-volt DC two-wire principle, two-wire communicating system. It could be up to 4. Most of the time we're using 2 wires to develop that 5-volt DC signal, but it is in reference to a ground or a common landed ground. And we have a positive signal that is in reference to ground and a negative signal that is in reference to ground. So how do we get to that point? Well, it's really not that complicated. It's very ingenious, but not incredibly complicated. We take our AC power source, starting at the furnace or air handler, our indoor unit, which is where our power source originates typically, right? That's where the power supply is. So we take our AC signal, we run that through some bridge rectification. We run it through diodes. We get that rectified into a DC signal, a reduced DC signal at about 5 volts DC. Then we will add a grounded reference point to it. And the network that we're going to talk about today, which is the Climate Talk network, which I would say that many manufacturers use this principle, we land that ground not exactly in the center of that 5-volt DC span. Remember, it's 5-volt DC, the height distance of our sine wave. We land it off center so that it is not directly in the middle of our reference point. So what we end up with in those 2 points is a 5-volt DC signal that is partially positive in reference to ground and partially negative in reference to ground. So now we have a place that we can start. Well, when we talk on that, we're not going to be able to listen in on what's being said on that, but we can verify if our network is working properly so that we can start looking for issues, right? So if we reflect back on this RS485 platform, and we can see here in the little red square that it is a two-wire data function primarily. This one is going to call it data plus and data negative. And then we might have our common and our ground, which is for our communication cable. But the work is really being done on those two terminals. Now, let's look at a couple different manufacturers, and we'll try not to use names on these. If you are a technician that reads your service and installation manuals, these wiring diagrams will look different. They're coming from different manufacturers. This particular one is actually the one that we'll talk about the most today, but let's hone in on what that communicating looks like from this manufacturer. We can see there where I put that little red square on our diagram, we are going to have a data line 1, a data line 2, then we're going to use 2 additional wires for 24 volts hot. Well, what are we doing that for? Well, our 24 volts hot, R and C, is the amount of current, the higher amount of current, the power that we're going to use to run that big fancy colored LED screen. It's also going to give us our capabilities of running Bluetooth and Wi-Fi and any type of a load that is on our controller. Data 1 and data 2 are going to be our 5 volt DC signals that we are going to use to communicate. That is our parallel communicating network. Well, let's look at another manufacturer. If I look at this wiring diagram, I go, my goodness. I have another positive and negative signal, and I'm using a common, so a ground reference point. So this particular manufacturer is using 3 wires. It is using common, which is a grounded common. So that is our ground reference point. It has a positive signal on A in reference to ground and a negative signal on B in reference to ground. If we look at this manufacturer, they are also using a 4-wire connection, but you'll notice they're using common and 24 volts AC for the load that is on the controller, and we're using data A and data B. It just happens to be our DC communicating signal. We look at this other manufacturer. If you look there in that little red square, we'll see that we have our common and our R, our 24 volt AC load. And then now we have, this one is labeling it as I negative and I positive. Looky there. We have a negative reference and we have a positive reference once again. If we look at this one, we're going to see a 4-wire connection. 2 of those, 24 volts AC, and 2 of those labeled as a positive DC and a negative DC. So we look at this manufacturer, another reference of the exact same thing. So I'm not saying that all manufacturers use the exact same, because I have seen some variations of it, but I will say that the philosophy, the technology behind it all comes from a similar design.
So what is Cocoon, right? And how does it work? How do we install it? And again, I wanted to touch on some of these other things, like where we're being put into the industry and different aspects of the industry that we're at. And in this, Cliff, we'll send this to you. If you go to our website and on our resources page, we've got a documentary there that we shot with PBS in 2020.
Yep,
and
seen that.
You can check all that out. Yep.
It's very interesting.
Thank you. So Cocoon, we're the first revolution in heating in over 100 years. Let's face it, an electric furnace has not changed. Everybody's
electric heat.
And they've been selling the same thing. Everybody's building the same exact thing. A toaster with a blower on it, right?
That's it.
And that's pretty much it. And, we're trying to, I like to tell people we are a path to energy independence. And, we are trying to eliminate the reliance on fossil fuels. Sure. We get those gas-like temperatures without all the kaboom. And, without all the issues here. And this picture that you see here on the right is actually a shipping container that I'm running 100% off grid. And we run a furnace and some camera systems and that kind of stuff. But,
sure.
We do some different testing and stuff like that in there. And then the other thing I wanted to mention, too, is that, we were verified by Underwriter Laboratories in 2018, 2019, that we use up to 41% less electricity to produce heat.
Than a standard electric furnace, which is pretty crazy.
That's right. Yeah. And so how does it work? It's
big question.
Call it, 4 to 5 key different elements. I mean, there's a lot more than that, but, these are the ones that we can, really touch on. And the thermal mass, it's a big hot rock, right? Inside of the furnace. It's not the toaster. The infrared heat, and I'll go over that in more detail, like where do we what is our furnace doing? Where does it line up in the infrared spectrum, and what kind of heat is it producing?
Sure.
The modular and scalability with the special design features, we do have a zero clearance install rating. We still recommend 1 inch around everything. It's just good common sense.
Yeah.
And then of course our controls and our control algorithms. What do we do with our controls and the control algorithms? Because of the thermal mass, we're able to offer some control aspects that you're not going to get with conventional equipment.
Mm-hmm.
So the thermal mass, what you're seeing here on the right-hand side is the inside of our furnace. You're getting a look under the hood here, So the big black portions that you see inside of there are heating panels. And there is 4 inside the four inside of each heating chamber. And where the screen mesh is, there's a heating panel underneath that as well. So you can see you got panel 1, 2, 3, and 4.
Mm-hmm.
Now, this is a very directional heat. Okay, so an open coil is going to throw that heat in a 360-degree radius, right? And we are trying to control that heat and control that energy and put it where we want it, which is right where that air is,
right. Not in the insulation.
Exactly, not in the insulation. Yeah. And so, once you have that thermal mass heated up, you can basically, you don't need the same amount of energy in order to keep that thermal mass hot. If you want to maintain a steady state, then yeah, you got to constantly dump energy into it. So one of the things that we do is we play upon the characteristics of the thermal mass, and you get a nice, more gradual curve than you do peaks and valleys when it comes to comfort and it comes to energy usage as well.
Okay.
We'll discuss that here in a second. So the infrared aspect. In the lower left here, you see that we have an open coil. When they run, they do produce light. And when we run, we do not produce any light. And so all light, if it's on a visible spectrum, is going to be just above the shortwave or a shortwave infrared spectrum of light.
Okay.
When our furnace runs, we're running a medium to long wave. So we're not producing light. So therefore, we're already saving energy when it comes to that. And kind of when I was talking about the curve aspect, you can kind of see here, even on the bottom of that chart in the upper right corner there, that as you get down into infrared, medium, long wave, microwave, so on and so forth, your curve becomes less of a peak and valley. And so we really see this in our energy when we capture the energy reports on the furnace. We really see that it's even much more spread out than that when you start to talk about how the furnace is affecting the home and what does that comfort look like.
After today, you're going to look at SEER 2 with a different perspective, and you're going to go, okay, that's not what I was expecting to happen. I know everyone's been saying that it's going to happen, but I didn't really expect it to happen this fast. It's a monumental change, but it's really not major things when we look at industries overall. If we look at what's happening with the HVAC industry, we can very much compare it to what has happened in the automotive industry for a couple of decades. If we look at energy efficiencies of automobiles and the technologies that have changed in them, we have had a very significant increase not only in the efficiency, but on the output of our internal combustion engines. Now, when we look at the HVAC industry, we've made some changes on our internal compression engines. Remember, our compressor is just a vapor pump driven by a motor. It's an internal compression system, but the efficiencies have not been driven anywhere similar to what has happened in into the automotive industry. Now, the automotive industry, they didn't revolutionize their entire industry. They didn't completely rework the internal combustion engine. They did a lot of modifications, particularly in the way that we control our internal combustion system. So we went from carburetors and points ignition and chain timing systems, mechanical components, over to things like fuel injection, electronic ignition, and variable valve timing. So the core of our internal combustion didn't really change. We just changed how we can manipulate the system to become more efficient. And we've been very successful at that. If we look at the HVAC industry, we are going through this revolution, and we hope that you are going to be prepared for that. We will be moving away from things like fixed orifices and contactors and single speed motors and compressors, going to new technology like thermostatic expansion valves, electronic expansion valves with control boards, and variable speed components in our motors and in our compressors. That is the reality of the world that we're going to be facing, particularly June 1st of next year. So, as students and technicians and educational facilities and institutions, we need to make sure that we are prepared for this, because you are going to become a new type of technician in the next few years. If we look at automotive technicians, an automotive technician relies on the internal components of those new systems to be able to do diagnostics and commission and be able to tune and tweak things, right? Same thing with us. We're going to be utilizing more technology that is already built into a lot of the equipment to be able to do self-diagnostics and be able to look at troubleshooting and things that we have been utilizing in the commercial and industrial environment for a long time, but not really in the residential. It's going to happen now. And it's going to have a fund driven behind it that's going to encourage the country to start upgrading into new technologies. So not only are we talking about equipment replacements for failed systems, we're going to be encouraged to upgrade equipment into higher efficiency systems, moving away from our legacy mechanical systems. Now, you will hear a lot of things about the Inflation Reduction Act. And one of the big things that stands out is a $4 million piece or $4 billion piece of that is going to be going for energy renewable products in the HVAC industry. But just today, we had a new release from the U.S. Department of Treasury talking about the big umbrella of energy and climate change that is coming to America. We're talking about $369 billion going towards climate change investment over the next decade, the next 10 years. And a lot of that is going to be focused on inefficient components within our space. A big one is us. And so that's what we're going to do today. We're going to dive a little bit deeper into what this means to you, what you're going to be seeing going forward, and give you the opportunity to be well prepared for these changes. So thank you for joining us. And David Brannon from Rheem, man, we are excited to have you here. And we're very blessed to have Rheem on the forefront of educating our industry with what these changes look like. So David, thank you for joining us. So what are we going to get into today? Where do we even want to start with this?
Hey, Clifton. Yeah, great to be here. I'm happy to help. So we're going to talk about kind of where the M1 regulations are taking us as a company, what we're doing with our equipment, what that's going to look like in the industry, and it doesn't really stop there. So, as soon as we get done with this Tier 2, we're going to be looking at a refrigerant change away from 410A. They're revamping the Energy Star right now, so that's going to change a lot from the municipality standpoint. Building code is all fixing to get rewritten for the A2Ls, and then
That's right.
electric companies are looking at demand response, and you got the big D word out there, decarbonization.
Man, first couple of times that I started talking about decarbonization and electrification on this particular program, boy, I got a ringer from some educational institutions and some management within that didn't really want to talk about that yet. And if we're not ready to talk about it, you're going to be. So very, very good topic to hear from our manufacturers.
Yeah. We're not going to get into that today, but
No.
the big change that we've got going on right now is the M1 standard. So that's a testing standard written by ASHRAE, and the big change that's dropping the efficiencies down is the wattage. So we're going from 365 watts per thousand CFM to 441 watts per thousand CFM, and a total external from 0.2 to a total external 2.5, which realistically is
More
still
realistic,
lower than
still
what we
low.
see. Yeah.
Oh, absolutely. I've always said in our industry, 0.5 is difficult in the Midwest. So there are many places in the country that 0.5 is rarely realistic, even on brand new constructions.
Yeah, the industry here has been, flex duct and ductboard for
Forever.
a good 10 years, maybe
Yeah.
15, and you're not gonna, you just don't see them installed at 0.5. So
Very, very rarely. I've seen many well above 1.0 on new installations and done site
Yep.
visits, exactly like you've been doing today. Going
Yep.
out to look at a piece of equipment and go, well, it can't perform when it's outside of these parameters. So a much different parameter set to work with.
Yep. And then, like we discussed earlier, the federal north map and the heat pump map, well, we'll mention here, is all based on a manufacturer date. So the gray states if it's an air conditioner, it can be sold as long as it was manufactured before December 31st. But in the red states down below, the south states, southeast, southwest, all that is written on an install date. So that
Right.
means, if it's not SEER 2 rated, December 31st is the last day that you can install it, register it, period.
Wow. It's going to play a lot of change on our distributors as they start relooking at allocating equipment into other sectors. So it's not something that is just affecting the technicians on the ground. This is something that's affecting an entire industry, from manufacturing to distribution to a piece of equipment on the ground that a technician has to look at and go, can I even install this in my area? Big
Yep.
changes.
Yep. So we've got distributors, our last order date for M product was probably 4 months ago. So whatever
Oh,
they ordered then, they'll get
that was it.
if it's built by December 31st. And
Sure.
if it's not, then, the simple reality is, you're basically taking something that would rate 15.5 to 16 SEER today, re-rating it if you were going to do that. And it would be, 14.3 SEER 2 is minimum.
Sure.
And now you've got what a high efficiency piece of equipment now being called entry level.
Yeah, exactly. And that's the big change. When people first started talking about SEER 2, the philosophy was, oh, well, it's only going to affect certain pieces of equipment, not realizing this is changing our entire equipment matchup. This is not where we're just going to make things a little bit more efficient. This is an entire matchup from manufacturers are going to have to be realigned and have new match and new ratings.
Yep. So here we're talking about the minimum efficiency. So I mentioned earlier 14.3. So in the southeast where I'm at, in the southwest, 14.3 is the minimum SEER 2 rating for a piece of air conditioning equipment, up to
Hmm.
45,000 BTUs, and then over 45,000, it's 13.8 SEER 2. And then if you get into the southwest, you're also tied to a minimum EER2 efficiency,
For
and
heating
then
efficiency.
HSPF2 for heat pumps.
Wow. Pretty significant increase over what we've worked with in the past.
Yep.
So what is M1? When we start talking about M1, there's going to be a lot of people asking questions about M1 and how it affects SEER 2.
So it's a testing standard. So the equipment today is tested to the M standard, ASHRAE
Hmm.
M standard, and then M1 is just the first revision of the M standard. So it's how the piece of equipment is rated, which gives you a SEER rating with M and a SEER 2 rating with M1.
Okay. So we're just adapting some testing procedures that we've had, and we're now just setting a new updated standard for it.
Correct.
Okay.
And then the heat pumps aren't affected as hard. Now, we're not going to continue with our product line because we changed a lot of stuff with this new product line to get ready for the A2L changes. So even on heat
Sure.
pumps, our last order date has already happened. So on current heat pumps, and then the new heat pumps and the new air conditioners won't match the air handlers and coils that we're using today with the M product. So
Exactly.
even though you could sell that heat pump past January 1st of 2023, it it's buy them while you can get them.
And it's more so for just a retrofit application. If we're just changing an outdoor unit, now we've got a piece of equipment that would still match up with our existing coil. May have an uncertified rating, but at least it is purchasable for a replacement. So a lot of things that we've known should be done on a system and have up to this point been able to pass because they weren't new laws, new codes and requirements. So as we move into system codes and system matchups, we're going to see a lot less equipment replacement and now more system replacement. Yeah.
So this slide here is talking about, the options that you had as a manufacturer. So you had to make something rate SEER 2. So the option are obviously you could increase coil size and get a higher SEER rating, but the equipment's already so big that really isn't a realistic option. So
Mm,
for us, the option was to go ahead and re-gear for the A2L change, which effectively gave us more matchups because we're not just re-rating equipment that was already rated in a SEER rating. Plus, it allowed us to shrink our mid-tier stuff. Our 15 and 16 SEER 2 rated equipment is now being built in a 13 SEER rated cabinet. So it's shrinking in size instead of getting bigger.
Okay. All right. So that brings up some good questions about sizing, because that's always the fear when we start talking about new changes. Are we getting larger? Are we getting smaller? Are we going to horizontal discharge versus vertical discharge? So a lot of factors go into that. That really just kind of depends on the efficiency of the equipment once it gets to that matching, that qualification done through engineering. So
Yep.
very, very cool to see that.
So the big key here is how we shrunk the condensers as we went to a different size tubing. So instead of going to micro channel like you see some of the other manufacturers going
Right.
to right now, we go to a 7 millimeter diameter steel, copper, and aluminum tube and fin coil, but 7 millimeter tube versus 3/8 tube on the outdoor.
On the indoor, are we still? What are we?
Staying
What are
with
we doing
three
there?
eighths all aluminum, aluminum fin, aluminum tube on the indoor, still
Okay.
3/8,
So
but
good.
it'll be different matchups than we're using today.
Gotcha. Okay. Because that's one of the things that I've seen a little bit of is going from 3/8 to 7 millimeter on the indoor, but it typically does depend on whether we're using copper or aluminum because we're really looking for high capacity. We start looking at a large outdoor unit, we still got to get our capacity, our heat transfer through the indoor coil. So
Yep.
good to know. Those are still staying 3/8.
And then you're going to see a lot more, variable speed equipment. So two stage or inverter driven. Here it's showing you that some of our SKUs, about 30% of them are going away from scrolls and towards a twin rotary design, which gives us higher efficiencies and more capability to vary the speed of the compressor.
Okay. Yeah. So we're getting a little variety of capacities off from going into that twin chamber rotary.
Yep.
Okay.
And then more communication. So this pushes communicating systems down into the 15, 16 Series 2 level for us. And
Wow.
then obviously the 18 Series 2 stuff is full communicating.
Sure. Yeah, that's a big change because typically, in the past when we would see communicating, we're talking about 17 to 18 SEER and above only, not typically in our mid SEER equipment. So, we've seen that was going to happen, and to be able to know that now it's going into that mid tier, that was one of the reasons that we were talking with EWC a few weeks ago. So if anyone is not very comfortable with communicating systems, definitely go back and spend a little time with John Brown on our communicating zone control systems built by EWC that works on a 5-volt DC platform, because it really gives you a better understanding of that network, because we're going to see a lot more communicating stuff this next year.
Yep. So, I mean, realistically, you're going to see more manufacturers do this because you just can't hit the efficiency metrics that we're being asked to hit without having full control of your system.
So that brings up a good point, Luis. Part of what we're talking about is not only having your combustion analyzer for looking at the efficiency of your piece of equipment, we're looking at the total structure. So now we're looking at using a combustion analyzer, and we're looking at things like carbon monoxide in the structure. So how much more sensitive would our combustion analyzer be versus, say, one of our standalone plug-in carbon monoxide detectors?
So I think that the difference is, and we can look at this on one of the next slides, is home CO detectors are a lot different, though, than what a carbon monoxide detector or a combustion analyzer is going to be when you're using it as far as walking into a customer's home.
Right.
And I have the statistics on that we'll get to in just a minute there.
Excellent.
There's some things, though, that you really got to remember about carbon monoxide. And the thing that I just cannot stress enough is that it is colorless, it is odorless, and it is tasteless. If we've said it before in this presentation, even if you're not testing, you will not know.
Right.
And the dangers with carbon monoxide, right? So in small doses, it can create chronic illness. There was a story that came out of the Indianapolis a few years
Yeah,
ago.
right here locally.
It was, and it made national
Yep.
news. It was a story of a lady named Kathy, and she thought she had the flu for 10 years.
Isn't that crazy?
Thought she had the flu. I mean, and you read the story, and it's absolutely heartbreaking. And it turns out that she had just been suffering from carbon monoxide poisoning, and it was a low enough dose that it was just building up. So as she was unable to work, she was staying home more. Staying home more, her body wasn't able to purge that. And so that's the dangers. And I always want to say that I want to have a conversation with Kathy, and I want to ask her about her furnace in her house,
Yeah.
because that story was tied into a hot water heater.
Yeah, that's what I
Um,
thought was a hot water heater scenario.
yeah, and so it was. You can read the full story. We can add links at some point, but
Hmm.
my question that I like to ask contractors out there is, if you have a properly tuned combustion analyzer and you've done all of that startup, when you walk into that house, I'm going to guess she probably had a gas furnace too. And so, had one contractor have walked in with a properly tuned combustion analyzer into that house, they may have been able to detect that ambient air CO and saved her some of that time. So that's, why having it properly maintained and just carrying one with you. In worst case scenarios, you wind up with fatalities. We talk, I said that if you want to spend that day depressed reading them, there's a new story that comes out every day. Here in the Midwest, fall is under full swing, which means winter's right around the corner. And, you get that bad ice storm. People start running their generators. You hear those stories. You heard them all about in Texas. Was it last year or the year before when they lost all of
When they
that
lost
power
power.
because of the ice storms,
Right.
and the power grids? So, there's in the larger durations, it can be very fatal for you. Uh, we look at one of the things that you look at, if you talk to any of your first responders, 35 parts per million in the ambient air, which is, it's not the fatal level, but they want to be called, they want to come in, they want to be checking in, or they're going to be shutting off those devices before they're going to call anybody because
Right.
they have the appropriate protective wear to be able to go in there. And you know what? I think, obviously we want to make sure that our homeowners are safe. We want to make sure our business owners are safe. But quite frankly, I want to make sure that the contractors are safe. I've seen the places that you go into, and it's very important that your safety is a concern. You don't want to walk in. We've heard the stories through the industry. Contractor went down. They were checking a furnace. It was down in the basement. They started not feeling well. They sit down. Do they manage to get back up? That safety is a huge concern for us. If you don't test, you're not going to be sure. But the other thing
Louise,
is that,
I'm sorry.
yeah,
Yeah, I just wanted to tack on real quick. In your previous slide, you said 50,000 people a year go into the emergency room.
Right.
The problem is they don't say, "Oh, I have carbon monoxide poisoning. Let me go to the emergency room." So
Exactly.
they're going to and it's important that our viewers realize that they go to the hospital because they're nauseous, because they're throwing
Mhm.
up, because they're dizzy,
Something's just
with
not
all
right
the-
here with me.
and they don't know what it is.
Exactly.
So it's really, really important. And that was just to tie up, everything you said in a neat little package, because 50,000 people are going to the emergency room. But if you fall and you break your foot, you broke your foot. I'm going to
Right.
the
It's
hospital
apparent.
saying,
It's immediate response.
but
Yeah.
we go to the hospital because of all the external things, because we don't feel good. So we delay going, like you said, because, it's something I ate, it's something I did, it'll clear up. But like you said, it only gets worse. The more time you spend in your house and you're not going out, I'm supposed to go out to dinner, I'm staying home, and you're making the situation worse. And you just summed it up. I just wanted to put a neat little bow on that.
Oh yeah.
But
And
Yeah,
it's
no.
like you said, colorless, odorless, tasteless, but very deadly.
So that R32 is actually half of that R410A that you've been working with. So the 410A is a 50-50 blend of R32 and R125. So we're going to continue to use R32 in a variety of different applications. We're going to see R32 on its own, so it makes it a slightly flammable refrigerant. We added that 125 to alter the A2L back into an A1 category by reducing the flammability. So we're going to have things like R32 on its own. We're also going to start blending some of these HFCs with other HFOs like the automotive industry is using, like that 1234YF. So we're going to see refrigerants. A popular one we're going to see first of the year is R454B. So that is a 68.9% R32 and a 31.1% R1234YF blend. the thing to pay attention to, and it's kind of gotten overlooked. All of these have HFCs. So not only are we talking about equipment in already installed appliances, some that have been around for decades, we're talking about new equipment hitting the market January 1st. We know that we have things like SEER2 and we have things like A2L refrigerants. Now we can see what we're talking about. Yes, A2L refrigerants are here, but we have a variety of HFC refrigerants as part of that A2L lineup. So what happens for those refrigerants going forward? They are in a phase down, and that's the part that doesn't get discussed very much. So we're here today to talk about that. We're here to talk about recovery and how it will make things so much smoother going forward if we just pay attention to proper recovery and reclamation of refrigerants so that our supplies are available. So today we have a fantastic guest of the industry that is going to get us into the know. It's going to bring us into a better understanding of what that reclamation process is looking like and how our industry is going to be affected by our own personal choices and responsibilities in the industry. So Kate, thank you so much for joining us, and we're grateful to have you with us today.
Well, thank you so much for the opportunity. We're excited to talk about reclaimed refrigerant and the AIM Act and how we've been recovering and reclaiming refrigerant for years, but how we need to continue to step up our game.
Mm-hmm. Absolutely.
All right, so let's look at, I wanted to start off with just giving an overview about reclamation. I mentioned we've been reclaiming as an industry and as organizations refrigerant for many, many years. And in fact, Hudson was founded very early on a principle of reclaiming refrigerant. So Hudson's been a refrigerant reclaimer for more than 25 years.
Mm-hmm.
Yeah, very long time. And this is a publicly issued chart by the EPA. Annually, they collect all the information from all the EPA certified reclaimers here in the US. They consolidate that information and publish to industry what reclamation looks like on an annual basis. And what's troubling for those of us who pay attention, for those of us who are in the reclamation industry, is you'll see from 2017, reclamation on an annual basis has been declining, right? And so R22 has been the largest refrigerant that's been reclaimed over the course of the last 20 plus years. HFCs have taken off as, again, and when they started to be reported, this is a little deceiving. HFCs were only asked to be reported in 2017. They'd be reclaimed for years before.
I was going to ask that. That makes sense. Okay. Yeah.
But the EPA only started to ask for that data broken out in 2017.
Okay.
So again, you see a little bit of an uptick there in HFCs, but you see an overall downturn in reclamation in general. And that's the trend that we all need to reverse as we move forward with the AIM Act.
Yeah, so if we want to go to the next slide, some of the things that, I just like to put up is some bullet points. But, as you mentioned, the goal of this Soft Start Home is basically to reduce the inrush amps to the unit. So we have been able to document that we can get up to about 70% reduction in the inrush amps. So as you mentioned, 47 down to 14. My own unit was 65 down to 24. So, significant reduction in the inrush amps. So we have an energy, reducing device. As we mentioned, we're looking to help quiet the unit. As we all know, some of the, if you have an older unit that's loud, the compressor's kicking on, making all types of noises, that could be right outside your bedroom window. It could be outside your baby's room. It could be right next to where you're entertaining. We've all been places where, the condenser is right next to the patio and, you're trying to have gas people over and you can't hear. Because
absolutely. On startup. So I actually make a point in my video because I was very impressed. So, I'm a fanatic of audio quality. That's just me. I'm fairly in tune to frequency changes, and I have always loved the sound of an inverter when it fires up. Call me weird, call me working on in commercial environments where you've got 30 different compressors unloading and inverting and modulating with VFDs, but I love that sound of a soft startup. And so with my own unit, you actually hear an audio clip later. actually get that. You get that slower on startup that, I don't know, call me weird, but I love that sound. So
No,
was
I mean,
able
I
to
do
that.
too. And I think, as neighborhoods get, the houses get closer and closer together, that could be an issue,
Sure.
everything kind of firing up at one time.
Yeah.
People are sensitive to noise, some more than others. And, it's a real, it's a real issue where, people hear the compressor, kicking on and it bothers them. So, this is, one option to help do that. As we mentioned already, we look to extend the life of the compressor because we're reducing the inrush amps, which then helps,
Mechanical wear.
with the heat and
You
everything to the compressor. We allow for a possibility of backup power, whether portable generator, whole home generator, or solar with battery backup. You can do that now, as you mentioned. If you're at 14 amps on your home, right, and running at 8 or 9 amps, a smaller portable, generator, hooked up to, correctly to your home can power your air conditioner and now can power, your refrigerator and a few other lights and some charging, ports. So you can, be fairly comfortable during a blackout, so
Sure.
That's what we're looking to help do. We do obviously have some built-in surge protection from, low power spikes or, as you mentioned, overcurrent, and then helping, with the short cycling, again, with, being able to turn off and lock it out for 3 minutes and give it time to come back on. And then, again, we're pretty compatible with almost any residential unit out there, up to 6 tons.
So we're talking permanent split capacitor motor driven though. So
Correct.
we're not talking about adding it to an inverter. We're talking about things that are already using a run capacitor start, which a majority of our equipment, 16 and SEER and under, are permanent split capacitor, even if they're two-phase or two-stage equipment. Paul just made a good comment, an interesting point too. He says that Texas has been using mini soft starts for their generator cells since the freeze. So I imagine this is a big push now that people are starting to get an understanding of what soft start does for a generator.
Well, right. So I think you make great point, Paul. I think you said Paul, in the sense that, one of the examples I use all the time is just that, right? Texas and their freeze a couple years ago, pipes bursting, people are ice skating on their pool, whatever the case may be. They weren't ready for that. And how nice would it have been able to, fire up some backup power and be able to, not have those issues going on.
Think about the heat pumps. Think about the people that had a heat pump and thought, man, I've got a generator. I got a portable generator. Let me go see if I can hook it up and fire up my heat pump and at least get something running. And probably couldn't get their unit started because they didn't have enough current capability.
Right, because they have the outdoor unit that needs to fire up at, higher amps. And so the soft start would definitely help with that. Now, on the flip side, if they would have had, a propane or gas furnace, right, and all they needed to power up was the blower motor,
sure,
they probably could do that.
Yeah, so exactly. Great stuff.
Yeah, so this slide basically just shows, much like your own personal experience was, standard startups can be 65 to 85 amps, and after you're putting on the soft start home, we've seen an average reduction down between 18 and 28 amps. Big difference, again, in that inrush of amps, what that does to the compressor over time, and what, that could help with many different things, longevity and everything else. Here's the specs on it. As we've already talked about, it's a quick, easy install. You're pretty much taking off the outdoor panel. You're putting in right next to where, the capacitor and contactor are, and you're tying it in. And we do supply a color-coded, easy wiring diagram. If someone
based on brands too, it's not just a generic universal. There's a few different ones depending on the manufacturer of your equipment.
Correct. If you take off the panel and you give us that wiring schematic number, which is right on there, we actually take 24 hours or less. We can get back to you and give you exactly
So what are we talking about with the Inflation Reduction Act? Many people are unaware of how important, how impactful this is to the world and to the industry. Well, it is one piece of legislation that has been signed that is going to bring about a a significant amount of investment into change in the way that we utilize energy. And this is a piece of a worldwide effort to reduce our total CO2 emissions. Right? So we're all playing a part in the global reduction of greenhouse gases. Now, we are going to see some transitions in our industry due to this. It's been inevitable. Anyone who has really been around the automotive industry has seen that it's been happening there for decades. When we started the initiative to reduce CO2 emissions in the automotive industry, it was pretty drastic, pretty quick, and we are continuing to make changes in increasing the efficiency of our automobiles so that we can decrease the CO2 emissions. Now, what about the HVAC industry? Well, we talked about this a few months ago. We have been making some changes in our SEER requirements, and we've gained a little bit of momentum on that, but not as significant as it could be. Well, when we look back at what happened with the automotive industry, we took out things like carburetors and points ignition systems and timing chain-driven timing systems to go with things like fuel injection, electronic ignitions, and variable valve timing, right? Starting to get variable capacity out of our systems, our pieces of equipment. Well, when we talk about HVAC, we're going to start seeing some similar things in the HVAC industry. A lot of us have already noticed those. We've been moving away from things like fixed orifice pistons and contactors and single speed motors, going with things like thermostatic expansion valves and electronic expansion valves that utilize control boards and variable capacity compressors, right? Inverter driven systems. So we're going to spend some time today looking at how these inverter systems are bringing the efficiency to our industry and how things like the Inflation Reduction Act are going to make it a little bit easier for us to look at these transitions, because we're going to see a lot more heat pumps and especially cold climate heat pump technology. So we need to be prepared for that. And we can now talk about how we can make that a little easier on the budget, a little softer cushion in the wallet. So Jamie and Christian, we thank you for joining us, and let's talk a little bit about what the DOE is doing for us through the Inflation Reduction Act.
Sounds great. Thanks, Clifton. Yeah, so I wanted to get started by just talking about one of the newest actual incentives that's out right now. This was just announced by the energy.gov earlier in December.
Right.
And so this is a up to $2,000 tax credit for heat pumps, also includes heat pump water heaters. So we'll cover 30% of the cost, up to $2,000. And yeah, it's something that's available right now. It's through the Inflation Reduction Act, and yeah, can be used right at the moment.
So up until now, like through 2022, we did have some incentives. We had a $300 incentive for heat pumps, for geothermal heat pump installations, heat pump water heaters. But now we're talking about a 30%, up to 30% of the cost of installation, up to $2,000 per year. So a pretty significant change in the way that we're going to be applying tax credits towards our HVAC equipment.
Yeah, and also, this table, we've copied it from the DOE, but it's also just for the heat pump side of things, but there's also a lot of other efficiency rebates available for insulation, for windows, upgrading your electrical panel, all of those kind of things, because we know that it's really important to look at a home holistically when you're doing these kind of retrofits. And if you do enough weatherizing or efficiency improvements, now you don't need to put as large of a system in. So very, very helpful all around.
And that's something that a lot of our contractors are going to have to look at going forward is, we've had a lot of inefficient systems for decades, and we're starting to understand the importance of doing, package analysis, looking at the envelope of a structure to see what we can do to make improvements for that, right? We're starting to see a lot more, duct and envelope testing, blower door testing. We're starting to see the demand for efficiencies. We now have states and jurisdictions that are requiring blower door testing on new constructions to validate how tight the system is, and gives us the opportunity to potentially reduce the BTU load that is on the structure, so the capacity of the structure. So if we look at that and we start with, okay, what is our first steps? Are we just replacing a piece of equipment, or can we look at all of the options that we have? I highly recommend doing energy audits on our structure. We had no incentives up until now to do energy audits, but now we're looking at a 30% of the cost up to $150 to do a home energy audit to be able to assess, are we in a position where we can look at other home improvements? Because now if we're looking at a...
So you can hit set, and now you hear that fan kick on. So the fan is running to that 25 Pascal target. And we've got these green jog buttons here to go up 5 pascals. So we have it seeking 25, but if I walk around and everything looks good, I can just tap this until I get to 50.
Right. So I don't have to manually adjust this. I just put a number in there and the fan seems to get there by itself.
The manometer serves as your control too. It's kind of the brain of the whole system.
Gotcha. Sure, that's the digital input for the ECM style control. Yeah.
Yeah.
Okay.
So now we're telling it to seek 50. So it's getting on up there. If I have the fan wide open and I still can't reach 50, but I'm close, we've got this button that you can click to extrapolate the reading.
If it had reached 50, you mean? So let's say you're only getting to 40 and it won't go?
Yeah, I'm only getting to 40 and she's running wide open, then I can tap that button and it'll tell me what it would be if it could have reached 50.
If you could have got to 50.
Yeah.
In a very leaky building, that would be pretty helpful.
Yeah, but I mean, if you can only get to like 20, then it's not going to be accurate. You want to be at least somewhat close to that 50 Pascal target. Usually within, 15 Pascals. So if you can get to 35, it's good. But if it's below that, I really wouldn't trust that reading.
Time to abandon. And let you know too if your fellow technician came in the back door, didn't close it.
Exactly. Well, yeah. If you have a door open when this is running, you'll hear that fan ramp up trying to overcompensate for it.
Yeah, I bet.
Might actually slam the door shut.
Sure.
Yeah, depending on which way you have the fan going. So right here we're seeing about 570 CFM 50. So we can see CFM at 50. And if I wanted to, I could go into my settings. Let's say our building was 20,000 cubic feet. All right, we can change that too. We're testing a pretty small space here. So we'll just say 10,000 and hit set. Then I can go back in and choose ACH. So I'm getting 3.4 ACH 50 for my pretend house here that I'm testing.
Sure.
And by standard, that would be pretty tight.
Yeah, it would. There's not a lot of codes out there that require, less than 3. Usually it's within, 5 or 6 or 7.
Which brings up a point that we were kind of discussing earlier, Sam. One of our, I will say we'll use it as one of our examples today. One of the forefronts of doing blower door testing is the state of Florida. And in the state of Florida, we're looking at specifications between 3 and 7. So below 7 is acceptable. Anything below 3 is going to require outside air to compensate for that. So in that instance, we can't have too tight of a structure once we get below 3.
Yeah, well, yeah, once you get below 3, that's when, mechanical air, fresh air is required. But what some builders are doing to not have to worry about that is just adding holes somewhere to make it get above 3 so they don't have to deal with it, which is not the way to do it.
No.
But unfortunately, that is what's happening
Something
there.
we have
Florida's a special case. That's
Sure.
the only state that I know that has a code like that where they have kind of 2 different
parameters.
Targets and requiring 2 different things at those different targets there.
But as you get tighter, the air inside of your house starts to get staler. I mean, you have cooking odors and all of the other things that you do in the house, VOCs and things from off-gassing. You buy new furniture, carpeting, paint. All of these things, if you're below that 3 air changes per hour, that air is going to start to get really bad, really stale, and really bad for you. So
you're going to need some fresh air.
I mean, at that point, it would behoove you to bring in fresh air and not just start poking holes.
Yeah,
because you have that same air that's just circulating and collecting things, and it has no way to get in or out. So yeah, when you have a tighter building, you do want to introduce some kind of fresh air, even if it's positively pressurized ventilation, which is, when you have a duct going from the return side to the outside, you can put a slight pressure on the building envelope, which is, good in some cases because you're kind of pushing against it to keep stuff from coming in, and you're introducing new air all the time. So some people, it's kind of hard for them to wrap their heads around that. Well, like, okay, well, in the winter and the dead of summer, isn't that bad? Well, you're bringing in such a small amount of air. It's really not. It's a lot better than just having a leaky house. So
sure,
and it's going to go through the system to be conditioned before it hits the space, because you said we tie it into the return. And from there, it's going to go to the heat pump, to the air conditioner, to the furnace to be conditioned before it gets delivered to the space.
Yep. And it should be filtered before it hits the coil.
Exactly.
So,
and it will affect the, the load marginally. Depends on the size and the amount of air that we're bringing in.
And when you run your load calcs, you can go ahead and plan for that. And if you actually look at the pie chart, it's a very small sliver.
Yeah.
And because that house is so tight, I mean, if you size the unit properly anyway, you should have that capacity.
Exactly. Right. Yeah. It shouldn't be a deal breaker.
Thank you for joining Did You Know, the ESCO HVAC show, brought to you by the ESCO Institute and HVAC Excellence. Our mission is to bring the top educators of the industry here for you in a live, unique experience so that you can join us from multiple social platforms, all with the opportunity to ask questions, to be involved, and to learn about the things that are changing in our industry as they are changing. Subscribe to our YouTube channel to get notifications when we go live every week. Are you an educator looking for resources to be the best that you can be? Man, you're in the right place. And we invite you to come join us at the National HVACR Education Conference, where we bring all of these guests and many more, along with manufacturers and different organizations of the trade, so that we can all be in one place at one time and gather this information to make us better together. How do you learn more? Go to escogroup.org, select HVAC Excellence, and then the conference. I look forward to seeing you again next week on Did You Know, the ESCO HVAC show.